All right, so in this video, we're going to review lessons 62 and 63, which are mainly about fractions and mixed numbers. You might hear some little voices in the background. Just try to ignore those. They don't involve the math. But in lesson 62, we're writing mixed numbers as improper fractions. And so we want to think a mixed number is a combination of a whole number and a fraction. So you got some nice images. If you read over those examples, I highly advise you to draw a picture for at least one or two of them to help you understand that the mixed number, again, is a combination of whole numbers and fractional parts. So I've got 5 parts here. We're going to think I would color in 4 of them to represent 4 holes with a W. But I'm going to draw this last one into thirds, and I'm only going to shade 1/3 of it. So 1 plus 1 plus 1 plus 1 plus 1/3. That's where we get 4 1/3. Now, I want you to remember, however, that each one of these holes could have been divided into thirds, and all 3/3 would be shaded. So we want to think, well, that's 3/3 for each of these, and then the 1/3 at the end. Well, we have a shortcut. When you add repeatedly, we call that multiplication. So there's 3, 6, 9, 12 thirds plus one more. The answer to this should be 13 thirds based on my picture. Let's think about what I just said, though, that we've got multiplication to help us. That's on our side. What's really going on straight from the mixed number is that we're going to multiply the whole number times the denominator, 4 times 3, and then we're going to add the numerator, which is just 1. And all of that goes over the same denominator, 3. So 4 times 3 is 12 plus 1, or 13 over 3. And that's how those work. That's a pretty basic process. I think you've probably done that before, but if not, again, the algorithm is just multiply the whole number times the denominator and add the numerator. So if we take that into consideration, 7 and 5/6, remember, we're going to say 7 times 5. I'm sorry, messed it up already. 7 times 6 plus 5. So again, 7 times the denominator, add the numerator. All of that's going to go over 6. Remember, the denominator does not change. So I get 42 plus 5, that's 47 over 6. Now, that was lesson 62. In lesson 63, we are subtracting mixed numbers, and they're going to say, let's use the technique of regrouping. So if that was 62, let's take a look at 63. Scroll up a little bit here, and let's look at an example like, why don't we go over one of the practice set problems? So we have 8 2/3 minus 5 3/4. And we learned last week that you have to have a common denominator to add or subtract fractions. Well, the same is true for mixed numbers. So the regrouping strategy requires us to think about, well, I might not have enough from the first fraction to subtract the second. Remember, to do this, we started stacking things. So we stack them like this, and then hopefully you remember the first thing I said was, well, we're going to have a common denominator here between 2/3 and 3/4. So 2/3, 3/4. Let's think about that. What's the LCD between 3 and 4? And you might remember the automatic strategy is multiply the denominators. It won't always be the LCD, but it will be ACD, a common denominator. And in this case, it is actually the LCD. So 3 times 4. The largest number that can divide both 3 and 4 is 12. So I'm going to multiply by 4 here on top and bottom. That's going to give me my 12. Times 3 here. That's going to give me my 12. And so I have 9/12 and I have 8/12. And so essentially you figure out that we were actually trying to say 8 8/12 minus 5 9/12. So from there, we realize you can't say 8/12 minus 9/12 for now. And so we're going to borrow, right? We're going to borrow a whole from the 8. So it will become a 7. But that whole is going to take the form of 12/12. Again, think about what we talked about up here with a whole in the denominator. That's how we know that's going to be 12/12. So I'm going to rewrite my problem This is why you should show some work, folks. 7 and 20 over 12 minus 5 and 9 over 12. So again, think about where the 20 came from. 20 minus 9. I can go ahead and do that. I'm going to get 11 twelfths. Here, 7 minus 5 is 2. And that's my answer. So that's all there is to regrouping. We are basically separating some pieces to help us. We're borrowing from a whole, grouping the fraction with the whole so that we can subtract the fractional parts, and then the whole numbers take care of themselves.